Example problem 8 reads, a photon of light with an energy of 2.2 times 10 to the minus 19 joules is emitted. What is the frequency of this photon? So for these problems, there are two equations that you can use. You can either use E equals h times v, or C equals wavelength times v. You have to be very careful with V in these two problems because V actually equals frequency, not velocity in units of meters per second. So you can either put V in units of reciprocal seconds, which is s minus 1, or you can use Hz, hertz, which is what we've previously used in other PowerPoints. So I'm going to go ahead and stick with hertz since that's what we have used in other PowerPoints. So we know that there are two options for equations that we can use. We can use E equals h times v, or we can use C equals wavelength times v. Just writing down the variables that we have, we know that E, which is energy, equals 2.2 times 10 to the minus 19 joules. That's told in the problem right here. And we're asked for the frequency, which is V, in units of hertz or reciprocal seconds. So we have a formula that gives us the E variable that we already have, that allows us to calculate V, and that we can substitute a constant in for one of those variables. And so the formula that we're going to use here is E equals h times V, where h is going to be Planck's constant. So E, which is 2.2 times 10 to the minus 19 joules, equals h, which is Planck's constant, 6.626, times 10 to the minus 34 joule seconds times V. And so we're going to divide by Planck's constant, so 6.626 times 10 to the minus 34 joule seconds to get it to cancel, divided by 6.626 times 10 to the minus 34 joule seconds. And when you divide 2.2 times 10 to the minus 19 by 6.626 times 10 to the minus 34, you'll get that V equals 3.320, so 3.32 times 10 to the 14 hertz, or inverse seconds. And you can see here where joules cancels and you're left just with seconds. And so that is how you work example problem 8. Let me know if you have any questions.